Okay, so this is intro shadow video part 2 or video number 2. I have one thing that we need to fix. So we started out by going through the variables, what does and does not affect the length of the pendulum, or not the length of the pendulum, the length of the shadow. And so a moment ago I wrote f of x equals HD and L. So we want a function. And we're going to update this a little bit more so you can see how function notation would look. So we actually want this to be that the shadow length is written in terms of H, F, or H, D, and L. So shadow length is going to be a function, so F of H, D, and L. So if you would please update that function notation for the shadow equation. Okay, so shadow is S is going to be the shadow length, H is the height of the object, D is going to be distance from light, and L is going to be the height of the light. And so you have your sketch here. Again, you could just draw a stick person, labeling that H. It could be a person, it could be a building, anything. We can calculate the shadow. We want to, at the end of the unit, be able to calculate the shadow length for anything, knowing the height of this object, the distance away from the light the object is, and then the height of the light. So if we know those 3 measurements, we want to be able to output the shadow length. And again, we're going to look at geometry and see if we can find any correlation between these 3 lengths to output shadow length. And so then those were your variable definitions, okay, defining what each of those meant. And we call this our shadow model that we're going to focus on. So this is the lamp shadow. This is part 1 of the unit. Once we figure this out, we will then write the equation for what not a lamp producing the shadow, but the sun. And the sun's always moving, so that's going to be need to be a different equation that we produce. Okay? All right.